Hello builders. Today's lesson is 8.1 Context Windows and Token Budgets. A model only sees the text that you send with the current request. The question is not how large the context window is. The better engineering question is what must the model see right now to generate the right answer and what can stay out. Think of the context as the working set for one model call. That working set can include 5 different things. Instructions tell the model how to behave. Selected facts give the evidence that the model needs. Tool output brings in fresh results. Recent history preserves the conversation. The user request tells the model what to answer right now. By the way, the Python files referenced in this lesson are available in the GitHub repository listed at the bottom of the screen. Start by reserving room for the answer. If the prompt consumes the whole window, the model has no room to produce the response you wanted. In context_budget.py, the function reserve_response_budget makes that rule explicit. It subtracts the variable response_tokens and the variable safety_margin before any context items are selected. If the remaining budget is impossible, the function fails early. This is better than sending a prompt that will be truncated in a less visible place. Once the available prompt budget is known, context selection becomes a ranking problem. Pinned items come first because the agent cannot safely answer without them. High priority facts come next. The function stores chosen items in the variable selected and excluded items in the variable dropped. Then returns both groups. That detail matters. If the answer is wrong later, you need to know whether the model saw the refund policy, the user's latest request, and the relevant ticket. A missing fact is not model judgment. It is an input problem. More input does not mean the model will use every fact equally. A long context can still hide the fact that matters. The function edge_load_context keeps critical context separate from supporting context. The goal is to make the required facts visible, named, and placed near clear boundaries. Critical constraints and the latest user request should not disappear inside a wall of text. In test_context_budget_py, the tests check more than arithmetic. They check the memory policy. One test proves that response space is reserved. Another proves an impossible budget fails early. Another proves pinned and high priority items survive while lower value context is dropped. This is the habit to copy. When you build a prompt assembler, test the context that gets excluded as carefully as the context that gets included. A missing policy, dropped user request, or a hidden constraint can change the answer more than the model choice. Interview question. How do you manage a model's context window? Use this as your answer. I manage a context window by reserving output tokens first, then selecting the smallest working set the model needs for the current call. I pin the required facts, rank supporting context by relevance, and keep critical constraints in clearly labeled sections. I also log dropped context. When an answer fails, I want to know whether the model made a bad choice or whether the application left out the fact it needed.